This is Shantan Kumar, Assistant Professor, Department of Mathematics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today topic is the Cayley Hamilton theorem and applications and verification. As we know that before going to discuss that Cayley Hamilton theorem, we discussed based upon the characteristic equation, characteristic polynomial. Now we are going to discuss that based upon the characteristic equation and characteristic polynomial. That is the statement of the Cayley Hamilton theorem. The statement of the Cayley Hamilton theorem is nothing but every square matrix satisfies its own characteristic equation. That is nothing but we want to know that what is the meaning of the characteristic equation. As we studied previously, the characteristic equation is nothing but the delta of A minus lambda I is equal to 0. That means what we are going to find in the characteristic equation, that equation is clearly satisfied. That means the statement of the Cayley Hamilton theorem is equal to that every square matrix satisfies its own characteristic equation. And based upon this Cayley Hamilton theorem, now today we are going to discuss that applications of the Cayley Hamilton theorem. And first of all, the main applications of the Cayley Hamilton theorems are two types. One is finding the inverse of the matrix. Second one is to finding the powers of the given matrix. Now today we are going to discuss that only the verification of the Cayley Hamilton theorem based on the given matrix 2 by 2 square matrix and also the 3 by 3 square matrix. And according to that, whatever the given matrix, whether the given matrix is 2 by 2 or 3 by 3. Now first of all, only that 2 by 2 matrix only we are going to discuss. Here, according to that first condition, first of all, we need to find out what is the characteristic equation. And according to the characteristic equation is nothing but, as we know that the delta of A minus lambda I is equal to 0. And after getting that in terms of lambda, we need to replace lambda is equal to A. That is, the equation is considered any one of the equation, either it will be star. And again, in that equation, we need that A square. Therefore, from the given matrix A is equal to, we need to find out A square. And by getting that A square, we need to replace whatever we consider that is a star or something in equation 1. We need to replace that with the help of A and also getting the values A square. Then after that, by using that A and also A square, then we need to replace in the star equation. Then we verified is equal to 0. That means that is a verification of the Cayley Hamilton theorem. If you want to find that A inverse by using the Cayley Hamilton theorem, then the star equation is multiplication with A inverse. Then you need to find out the inverse of the matrix. Now we need to find out first of all the verification of the Cayley Hamilton theorem. Here the one of the problem that is assume that A is equal to 1, minus 1, 2, 3. And here the given matrix is order is 2 by 2 only. First of all, we need to find the characteristic equation of the given matrix A. That is, with the help of that characteristic equation of the matrix A is equal to, that is delta of A minus lambda I is equal to 0. And generally, we know that the standard equation is 2 by 2 matrix is given. We need to find out what is lambda square minus S1 lambda plus S2 is equal to 0. In that, we need to find out what is the equations of, that is the S1 value and S2 value. As we know that according to the 2 by 2 matrix or 3 by 3 matrix, that S1 is equal to the trace of the matrix. Therefore, that here trace is nothing but the sum of the diagonal. Here the diagonals are 1, 3. Therefore, the trace of the matrix is equal to 1 plus 3 is equal to 4. Second one, we need to find out that is S2. That S2 is nothing but the determinant of the given matrix. That is, data of the matrix is equal to, that is a 6 plus, that is a 2. Therefore, it is equal to the final solution is 5. Therefore, here data is equal to the given matrix is S2 is equal to 3 plus 2 is equal to 5 clearly. And by using this S1 and also S2, whatever we treated as according to the processor in that equation 1, when we are going to replace this S1 and S2, then the equation is reduced to like lambda square minus 4 lambda plus 5 is equal to 0. And now we want to verify the Cayley Hamilton theorem. According to this procedure, we need to replace lambda is equal to A. Therefore, by replacement of lambda in this equation, we obtain that is A square minus 4A plus 5y is equal to 0. This equation is treated as a second. Now we want to verify whether it is a square minus 5a plus 5y is equal to 0 or not. Due to that reason, first of all, we need to find out in this equation, that is what is the meaning of a square, what is the meaning of a, what is the meaning of I. As we know that A is equal to the given matrix, with the help of this A matrix, we need to find out what is the A square. That is with the help of that A into A. And again, I is equal to the matrix is a unit matrix. By solving that A square, that is with the help of the given matrix A into A, therefore the matrix is reduced to like -1, -4, 8, 7. Therefore, by using this second equation, when we are going to replace in that A square, and again by using the I value, therefore with the help of that A square minus 4a plus 5 is equal to, according to it is the values are -1, -4, 8, 7, -4 into, without that the A is equal to 1, -1, 2, 3. Therefore, by using here replace with multiplication with 4, the values are changed to like 4, -4, 8, 12, plus 5 into I is nothing but, here I is a unit matrix. With the help of that multiplication with 5, the values are changed to like 5, 0, 0, 5. And we need to find out, according to that addition including the subtraction with the help of these three matrices, the corresponding values are 1 by 1, -1, -4, plus 5. Second values are -4, -4, and it is equal to 0. The third value is also automatically there is no value. Second row corresponding like 8, -8, plus 0. The next value is also finally that is a 7, -12, plus 5. With the help of this addition of and including the subtraction, the final matrix is obtained clearly, that is 0, 0, 0, 0. Therefore, it is nothing but that obtained, that is a 0 is a matrix. Therefore, verified according to A square minus 4a plus 5y is equal to 0. This is the meaning of thus the Cayley Hamilton theorem. It is verified properly. Why? Because according to the statement of the Cayley Hamilton theorem, every square matrix satisfies its own characteristic equation. By the definition, by using the calculation, here we obtain the characteristic equation. That equation is satisfied the given matrix. Therefore, it is clearly satisfied the Cayley Hamilton theorem. For example, the statement, once again, it is remember that every square matrix satisfies its own characteristic equation. For example, you take one other example, that is for a matrix A is equal to 1, 3, 4, 5. And based upon this equation is also, when we are verifying that Cayley Hamilton theorem, that is we need to find out what is the characteristic equation, that is delta of A minus lambda I is equal to 0. Here, by solving this matrix and including the lambda is a scalar and I is a unit matrix of order 2, the equation is reduced to lambda square minus 6 lambda minus 7 is equal to 0. Now this equation we want to verify whether it is satisfied or not by taking that according to replacement of lambda is equal to A. When we want to verify that A square minus 6a minus 7 is equal to 0. Due to that reason, again when we are going to finding that with the help of the given matrix A, we need to find out A square, that is A into A. By solving that A square, we obtain clearly 13, 18, 24, 37 minus 6 into A is the multiplied, then we obtain that is 6, 18, 24, 30 minus 7 into I is also we obtain clearly 7, 0, 0, 7. And finally, by using that subtraction and including that addition of the matrices, then we obtain that finally the matrix is a 0, 0, 0, 0. That is nothing but verified the Cayley Hamilton theorem. And conclusion of that, here also the square matrix is satisfied the Cayley Hamilton theorem. And next one, for example, we need to verify the matrix is the given matrix, that is verified that Cayley Hamilton theorem. But here the matrix is given that is a 3 by 3 order. What we are observing the previous problems are that is a 2 by 2 matrix. But here this the problem is a 3 by 3 matrix. Here the elements are corresponding 1 by 1 to -1, 1, -1, 2, -1, 1, -1, 2. And with the help of this the given matrix, we need to find out what is the characteristic equation. Therefore, the characteristic equation of the given matrix A is equal to the delta of A minus lambda is equal to 0. We need the equation is like standard equation, that is a 3 by 3 matrix. with the help of the data of A minus lambda I is equal to 0, that is lambda cube minus S1 lambda square plus S2 lambda minus S3 is equal to 0, where it is also equation is treated as a 1, where here S1 is equal to the trace of the matrix. Already we discussed the previously in the previous sessions, and here also S1 is equal to trace of A, that is nothing but the sum of the diagonal elements. Here the diagonal elements are 2, 2, 2, therefore 2 plus 2 plus 2 is equal to the value is 6. And similarly, we need to find out what is the S2. That S2 is equal to, that is sum of the minus of the principal diagonal elements of the given matrix. Here the principal diagonal elements are 2, 2, 2. Now we want to find out what is the first, that is a 2 elements, that is a 2 minus 1 minus 1 2. And next one, that is a 2, once again one more, that eigenvalues, that is a principal minor, that is equal to also 2, 1, 1, 2. And the third one is also the minors of the principal diagonal elements, 2, minus 1, minus 1, 2. And you need to find out the 2 by 2 dead individually these three matrices. And finally, we obtain that is equal to S2 is equal to clearly 3 plus 3 plus 3, that is a corresponding, that is the 2 by 2 determinant values. And finally, that S2 is equal to 9 is the value. And here we need to find out what is the S3. According to that S3, the determinant of the given matrix. The data of the given matrix, as we know that how to find the value of the data of the matrix. Therefore, by using the data of this matrix, that is 3 by 3, the values are clearly 2 into, that is 4 minus 1 plus 1 into, that is minus 2 plus 1 plus 1 into 1 minus 2. By solving, that is simplified, then we obtain the value is equal to 4. Therefore, now here completed S1, S2, S3. Therefore, putting these values, that is S1, S2, S3 in what we are treated as equation 1. By solving that, by replacement of here, that is a lambda cube minus S1 lambda square plus S2 lambda minus S3 is equal to 0 is reduced to clearly, that is lambda cube minus 6 lambda square plus 9 lambda minus 4 is equal to 0. Therefore, it is a equation is treated as a 2. Then now we want to verify whether this equation is a Cayley Hamilton theorem is satisfied or not. According to that verification of the Cayley Hamilton theorem, this equation is when we are going to replace that lambda is equal to a, that final equation we want to verify, there is a cube minus 6a square plus 9a minus 4i is equal to 0. That we want to verify whether it is satisfied or not. And in this equation, we want to require to know that what is the meaning of I, what is the meaning of a, what is the meaning of a square, what is the meaning of a cube. According to, we know that in this given matrix A is equal to, given that we know that properly, and I is also we know that, assume that is a given matrix is a 3 by 3 order, such that you take that I is also, that is a unit matrix of order 3 by 3, that is a 1 0 0 0 1 0 0 0 1. And A2 we need to find out first of all that according to S2 is equal to, that is A square is equal to A into A. As you know that A is a matrix, that is a 2 minus 1 1 minus 1 2 minus 1 1 minus 1 2. The product of once again the given matrix, that is a 2 minus 1 1 minus 1 2 minus 1 1 minus 1 2. Therefore, with the help of this 3 by 3 matrix, by the product of that is a multiplication, we obtain that clearly the values are respective like 6 minus 5 5 minus 5 6 minus 5 5 minus 5 6. And now we want to find out one more, the value, that is a cube. That a cube is equal to a square into a. And again we already completed, that is a square. Therefore, with the help of the given matrix a square into the given matrix is equal to, that is 6 minus 5 5 minus 5 6 minus 5 5 minus 5 6. And into the given matrix is also once again the 2 minus 1 1 minus 1 2 minus 1 1 minus 1 2. Then according to this, the product of the 3 by 3, clearly we obtain that the corresponding the respective values are, that is 22 minus 21 21 minus 21 22 minus 21. The last row it is 21 minus 21 22. Now after getting this a cube and a square and consider the matrix I with the help of these three matrices, then when we are going to replace in the equation, that is a cube minus 6a square plus 9a minus 4y is equal to, according to that, that is 22 minus 21, the 21 minus 21, 22, minus 21, 21, minus 21, 22, and similarly the remaining a square and a and also I. Then when we are going to replace all these matrices in the matrix in the equation of a cube minus 6a square plus 9a minus 4i, by solving this 3 and 4 matrices by addition and subtraction, finally we obtain that clearly that 0, 0, 0, 0, 0, 0, 0, 0, 0. That means which is clearly satisfied 0. Therefore, if it is a cube minus 6a square plus 9a minus 4i is equal to 0, thus the meaning of the given matrix is satisfied the characteristic equation. Therefore, this is the meaning of thus the Cayley Hamilton theorem is verified the given matrix. And one more problem, when we are going to verify the Cayley Hamilton theorem for the matrix here A is equal to, the values are similarly here also 1, 1, 2, 3, 1, 1, 2, 3, 1. Here also, first of all, we need to find out what is the characteristic equation of the given matrix A. And according to here also, that every square matrix can be expressed as a uniquely expressed. It is also, we need to show that that is a characteristic equation of the matrix A is satisfied the given matrix. Therefore, here also, according to the 3 by 3 matrix, now we need to find out what is the general equation of the third order. Therefore, the lambda cube minus s1 lambda square plus s2 lambda minus s3 is equal to 0. Therefore, here also that s1 is equal to the trace of the matrix. Here the trace of the matrix is equal to the corresponding the diagonal elements. The diagonal elements are here clearly 1 plus 1 plus 1 is equal to 3. And similarly, we need to find out what is the S2 matrix, S2 value. Here S2 is also the sum of the minors of the principal diagonal elements of the given matrix. Here that principal diagonal elements are 1, 1, 1. Now we need to find out corresponding these 3, what are the minors of the values. Therefore, S2 is equal to, first one is a det of 1, 1, 3, 1. The second one is also the minor is a 1, 2, 2, 1. The third one is also minor is a 1, 1, 3, 1. Then according to addition of these 3, sum of the minors of the diagonal elements, by using the determinant individually, by solving this equation or this matrices, then you obtain the solution is a minus 2, minus 3, minus 2 is equal to, that is the value is a minus 7. And similarly, we need to find out what is a S3. That S3 is equal to the determinant of the given matrix. The determinant of the given matrix is equal to here the data of 1, 1, 2, 3, 1, 1, 2, 3, 1. That with the help of this 3 by 3 determinant, by solving, we obtain clearly the value is equal to, that is 11. Therefore, here we concluded the values are we obtain clearly S1, S2 and S3. By getting these 3 values, when we are going to replace in the equation 1, that is the lambda cube minus s1 lambda square plus s2 minus s3 is equal to 0 is changed to like lambda cube minus 3 lambda square minus 7 lambda minus 11 is equal to 0. This equation, if it is treated as the second one, now this second equation is we want to verify that is satisfied the characteristic equation. That is the replacement of, according to the Cayley Hamilton theorem, we are going to replace the lambda is equal to a. Therefore, that is the meaning is verified, that is a cube minus 3a square minus 7a minus 11 into I is equal to 0. And here, once again, we need to require to know that what is the meaning of a cube, what is the value of a square, what is the value of a, and what is the value of I. And again here, a is equal to, that is a given matrix as we know that, and I, that is also unit matrix of order. The given matrix is 3 by 3. Let us assume that is 1, 0, 0, 0, 1, 0, 0, 0, 1. Now we need to find out first of all what is a square. That a square is equal to, that is a into a. And a is equal to here clearly we know that 1, 1, 2, 3, 1, 1, 2, 3, 1. And one more a, it is equal to, once again it is repeated 1, 1, 2, 3, 1, 1, 2, 3, 1. By solving this, the product of a into a is equal to, the value is obtained, the matrix is clearly, that is 8, 8, 5, 8, 7, 8, 13, 8, 8. And similarly, now we want to find out that is a cube. Therefore, a cube is equal to a square into I. Here a square is equal to, already we completed, the value is equal to 885, 878, 1388, and one more a is equal to, that is a given matrix, that is a 1, 1, 2, 3, 1, 1, 2, 3, 1. By solving this, is the a square into a is equal to, clearly we obtain, that is a 42, 31, 29, 45, 39, 31, 53, 45, 42. Now, whatever the equation treated as the second one, that is a cube minus 3a square minus 7a minus 11 into I. In this equation, according to one by one, when we are going to replace, that is a cube and also 42, 31, 29, 45, 39, 31, 53, 45, 42. And similarly, we know that a square is equal to, that also when we are going to replace in this equation, that is a minus into, after that multiplication with 3, the values are changed to 24, 24, 15, 24, 21, 24, 39, 24, 24. Next one, with the help of the given matrix A, that is a minus into, that is a 7, 7, 14, 21, 7, 7, 14, 21, 7. And next, with the help of the given matrix, that is unit matrix, assume that is I, with the help of this matrix, that is minus into 11, 0, 0, 0, 11, 0, 0, 0, 11. And with the help of these four matrices, including by addition and also subtraction, one by one all the corresponding values, the matrix is reduced to clearly, that is 0, 0, 0, 0, 0, 0, and last row is also changed to like 0, 0, 0. According to that, 42 minus 24 minus 7 minus 11 is equal to 0. 31 minus 24 minus 7 minus 0 is equal to 0. And last value, 29 minus 15 minus 14 minus 0 is equal to 0. Similarly, when you are doing according to this by using these four matrices, the entire matrix is reduced to, all the values are, it will be changes to 0. That means the matrix is equal to clearly 0. Therefore, a cube minus 3a square minus 3a minus 11 into I is equal to 0. Thus, the meaning is verified the Cayley Hamilton theorem. This is the meaning of every characteristic equation is satisfied the given matrix. That is, with the help of the Cayley Hamilton theorem is nothing but the square matrix is satisfied the characteristic equation. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.